Here's the explanation for the answer to final exam question number 53, found on page 672 of Teach Yourself Electricity and Electronics, 5th edition. The question asks us what the suppressor grid in a pentode vacuum tube is intended for or can help to do. This is a schematic symbol of a pentode tube, a kind of a generic amplifier circuit. The lower grid here is the control grid. That's where the input signal comes in. This grid is the screen grid, which helps to reduce the capacitance between the control grid and the plate. The screen grid normally gets a positive voltage that is a fraction of the high voltage, or HV, that the plate gets. The suppressor grid is normally grounded, and in some vacuum tubes it's actually shorted out internally to the cathode. The purpose of this suppressor grid is to provide additional isolation between the control grid and the plate. Sometimes the screen grid alone is not enough to completely get rid of the capacitance between the plate and the control grid, or at least not to the extent necessary in certain types of amplifiers. So this suppressor grid provides some extra reduction in that capacitance. The correct answer to this question, therefore, is A, as in alpha. Now I might add that the suppressor grid can perform other functions besides just reducing that capacitance. In some vacuum tubes, the electrons strike the plate with such force that they dislodge electrons from atoms in the plate itself, and those electrons can go back and be conducted out the screen grid and cause what they call excessive screen grid current. Well, those electrons that get sucked off by the screen grid that way are electrons that can never contribute to the output. What they call secondary emission from the plate, or secondary electron emission, can rob the tube of some of the gain that we could otherwise get. So, by inserting a suppressor grid here, which in effect has a negative charge with respect to the plate, it helps to repel those secondary electrons and force them back to the plate at a slower speed than they originally struck, so they can go out and contribute to the output. It's kind of ironic that you could place an isolation element like that in between the control grid and the plate and actually get an increase in the gain that the tube can provide. But that suppressor grid can also do that. However, that isn't any of the choices in this question. The only choice that's relevant has to do with the capacitance between the control grid and the plate, and once again, that is choice A, as in alpha.